this is a huge stage. I really don't know what to do with this. Should I go closer to you or should I get up further? I just see that a lot of people are filming. If you film vertically, God kicks a puppy. Always do it sideways. These are awful, awful videos on the internet, so please always do it sideways. Cinemas are not high, they're wide. So always think about that when you do movies. So I want to talk to you today to start this off about building more human interfaces using machine learning and using technology. This sounds like weird because we actually use machines to do things that humans don't understand. As a developer, people always think like we're doing these magical things that nobody understands. My parents, for 20 years, didn't know what I was doing. Whenever people came and visited them, and they're like, "What's your son doing for work?" They're like, "Oh, I don't know, do you want another coffee?" And then I wrote my first book, and then they had something in their hand to show to people. So they're basically like, he does this, and then they're happy, and they have to look at the book, even though it's in English, and nobody knows what's going on there. But they understood that doing something physical, making something more approachable for people, makes computers less scary and less problematic. And this is a world we live in right now. So to start with, let's have a bit of a prologue. Who are these people, and what do they have in common? This is George Orwell. This is Arthur C. Clarke. This is Aldous Huxley. And this is not Santa Claus impersonator, that's actually Alan Moore. And these are all people that wrote dystopian novels or dystopian comic books or graphic novels in the case of Alan Moore. And whenever we talk about machines and learning machines and automation, they always come up and then they vanish. Okay, technology problems. Are we getting this back now? Did I do something wrong? Oh, we're starting on a good start. Fair enough. I have no screen here. That's okay, so I just keep on going. So all of these people are authors of dystopian novels that showed us that the future is dangerous, that the future is actually something that we should be worried about, that machines are going to take over, that machines are going to take away our freedom, that we're going to be just a cog in the machine and we're not going to be allowed to be creative, allowed to be human, allowed to be a person. But instead, the governments will control all our thoughts. The governments will control our feelings, and we'll be there just to do a menial task and boring work, and we should be afraid of governments and everybody around there. So, this is really good. I'm not doing anything here right now. The seminal work that people are always talking about here is 1984, the book that is written in 1948, and he just turned it around and said, like, the future is going to be a terrible, terrible world where where machines are basically there to control the humans, and the government will not allow people to speak anymore. The government will not. Woohoo! Sponsored by AS Rock. Oh, you gotta be kidding me. The fun thing is, my presentation is in Keynote on a Mac, so I don't know what's going on here right now. But in any case, 1984 is always the message where people give, okay, computers will be there to look at people. There will be a camera on every corner where people are being filmed. The government will spy on you, and you will not know, you will not be able to hide, and the government will be after you. Alan Moore's V for Vendetta took the same thing and said, like, this is what a British government could be like in the future if we went back to this kind of idea of a controlling state that actually doesn't allow you any freedom and will be there for you to go through that. I can't even go forward on this, but okay, fair enough, we have it. You don't have it yet, but I have it, so that's good. So V for Vendetta was a graphic novel that was kind of in the same vein as 1984, that tells you the government will be controlling you and the government will be shutting you down. Of course, nowadays, this is not an issue any longer because we're in a much more enlightened way. We have governments that don't want to control us, that trust us with their information, and they actually don't want to do things like that, except some of the governments are going back in these reactionary phases where they start using the power of terrorism or the danger of terrorism to say, like, we should be there to control you. And this is what 1984 was kind of about as well. So it's no wonder that people are kind of worried about technology, that people are worried about computers, that people are thinking that thinking computers and automation will be against their lives, will be against their work. In Arthur C. Clarke's 2001, which is a beautiful, beautiful movie by Stanley Kubrick, one of the best movies ever done, they had this HAL 9000 computer, that thing in the background here, that was basically a thinking computer. And it was controlling the whole space station, and then it got crazy. Something went wrong with the chips, and it started going after the people and killing them. That's a thing in every science fiction movie. In like Star Trek, the original series, always had a computer that was meant to actually cleanse the world of imperfection, and then they realized that humans are not perfect, and they started going after humans. Terminator had the same thing. People were basically always afraid of killing machines, killing robots that actually go after us. Which is kind of weird, because computers don't care. They're just like, why should we kill humans when we can actually make them work for us instead? And a lot of science fiction has this the total way around. You see, for example, in Total Recall, they have robots that are police officers. And they go through the streets and hold up the peace. And then they have humans in factories building robots. That makes no sense whatsoever. Like, why should we have robots that are police officers but not have robots building other robots? Why should humans do that? But we still had that. In one of the main highlights of 2001, they tried to hide from HAL because it has microphones everywhere and listens in on their conversations. So they're going into this pod to hide away from the robot or hide away from the microphones and communicate there with each other. Now, what they hadn't thought of is that the computer can lip read. So it actually realized from what they were saying, what they were doing. And this was a scary moment for us. Like, if computers get that good that they can start lip reading and they don't even have to listen in on us, then we're really in trouble, right? Now, Google's DeepMind has this right now. There is an algorithm, and there's actually an API as well, where you can lip read from video and turn it into subtitles. And an average human subtitling or lip reader has 12% quality, whereas this algorithm had 46.8% quality in English, of course. Like, everything is much easier in English because SPO and these kind of things is much, much easier. But we are there. And Aldous Huxley, the writer of Brave New World, and also the French teacher, weirdly enough, of George Orwell, said technological progress has merely provided us with more efficient means to go backwards. And this is kind of happening right now. People are talking about a digital feudalism, where only a few of us can afford these very, very expensive phones, these very, very expensive computers. We're living in a bubble where we at these events where we're talking about everybody has a MacBook Pro. Why should I actually care about other platforms and these kind of things? And we're not using technology to bring the whole of humanity forwards. We could be putting more effort into like trying to solve cancer, trying to solve world hunger, but instead we're talking to each other who's got the biggest online platform for buying collectible sneakers of each other and things like that. That's where the funding goes. Or we could use Twitter to support people with each other, but instead we do it to bully each other people. So that's really weird as well. Brave New World was a very, very exciting book, and I've read it many, many times. Because one thing that Aldous Huxley was kind of predicting that is true is that a part of humanity, the ones that actually have the money, the ones that have the power, are totally concentrating on not on educating themselves, not on educating other people, but on entertaining themselves. We're in a world where we use the best, coolest new technology to do entertainment things. Netflix is a great example. It gave us like video on demand, and we can watch things. And Netflix does deep machine learning on their compression algorithm to give us the best quality video depending on what's on the screen. So darker screens can get compressed more, lighter screens can get less compression, so the quality doesn't go down. But what he also predicted was there is going to be a separation of haves and have-nots. What Brave New World did, of course, is tell people, okay, you're born that way. They poison the water of children in test tubes that they're stupid and other people are not that stupid. But we're not in a world where this is not that uncommon. My parents have never had a proper school education. My dad's a coal miner, then he was a factory worker. My brother's a fireman, and he was a factory worker. Their whole life, they've been told by their peers that they're not good enough, that they're not clever enough, that they can't do the things that I could do, these computer things. I got the same DNA as them. I just didn't give a shit. I just went for it, you know. I just said like, okay, I'm in the right moment, the right time. I'm gonna learn this. I don't wait for a school to tell me. I'm just gonna go for it. But we voluntarily go into different castes and basically become the things that our parents were, rather than moving humanity ahead. And what he didn't predict is that we bought all these machines that spy on us. We bought these cameras that monitor our every move. We're actually going for it because it's cool to share things on Facebook. It's cool to have a live video on Meerkat or whatever these things are right now. People give away their freedom. People give away their information. People give away their data for free services that then 4 months later are dead. But the data has been mined, the data has been taken somewhere, your information is stored somewhere, and you have no idea if it's stored securely. And even governments do that wrong. I'm always fascinated when people are all about, the government is spying on us and is going to do evil things with that. What most conspiracy theorists are not understanding is that they're assuming governments to be capable. They're humans, they make mistakes as well, all the time. So when they tell me that they're the only one who can protect me, I'm not believing this for a second. Now, on the other hand, I'm a happy person. I like technology, and I love what I can do with technology to teach other people what I'm doing. So if you follow me on Twitter, at CodePoet, or you go to my blog, I share everything I do. Because if I get run over tomorrow by a truck, all my information is out there, and people can run with it and do something with it. I embrace the future of computing. I embrace that computers are there to make our lives easier. So, creature comforts we all enjoy. Let's take a look at what computers are actually doing for us that we don't quite realize. How much is that in part of our life already? So things machines do for us. The first thing is they prevent us from making mistakes. Then they actually do boring, repetitive tasks. They fill gaps in information. They remember and categorize for us. They make us understand better. They allow us to communicate more. And they protect us from harm. And this I will go through now in details so you actually know what's going on. So the first thing is they stop us from doing stupid things. And these are things we don't value. Every time you write something in Word or any other editor, you type something wrong, it gives you the offer saying like, hey, actually you did a mistake here. This is a spelling mistake. This is a very simple mistake not to do. So, do you want me to fix it for you? How cool is that? You know, it's like you're not appearing stupid to people out there. The computer is helping you not to do that thing wrong. And yet people send out emails without getting rid of those squiggly lines and basically think it's too much work. I mean, how amazing is it that you can learn a language that way? Do boring, repetitive tasks. JP Morgan just announced that they have a new software that can do in seconds what cost their lawyers to do things in hours and hours, 360,000 hours or something like that. Oh, you gotta be kidding me. So what the thing does, it's actually, we always think lawyers have to be very clever people and not computers at all. But a lot of the job of a lawyer is to find a court case from the past where something has happened already. And this is what lawyers do. So computers are really good at doing boring, repetitive tasks over and over again. They're like, hey, I got the same job again, cool. Humans instead like, oh, got the same thing to do again. Like I give any of you the same task to do 10 times in a row, like keeping a projector up, and you'll be like, I don't want to do it anymore. This is boring. And when we're bored, we make mistakes. When we're bored, we don't do things with quality because we're bored. We don't want to do it anymore. Now, the other thing that we do is that what machines can do for humans is fill in gaps in information. And this has always been a thing, and you can imagine this now on the screen. I love this in science fiction movies. When you always get a CCTV footage, you know, there's some gray thing, and then they're like, oh, look, there's a hubcap. Can you zoom in on that and enhance it? And then, oh, look, that hubcap is reflecting from somebody's sunglasses, and they reflect from somebody's license plate, so I can actually read that one. So they always have this really, really, really small video with really bad resolution, but they find the most amazing things in it. Now, there is an algorithm like that now, and that not scared, but that confused the hell out of me because I always made that joke about computers will never be that good. They are that good right now. There's an algorithm called super resolution something. How is it? Pixel recursive super resolution. There's a paper out if you want to read that paper in case you suffer from insomnia or you basically understand these kind of things. You can read that one. And what it allows you to do is get from an 8 by 8 pixel grid of 4 pixels the in-betweens. So what they did is like they had like an image of like really, really blocky pixels, and they interpolated a face from it. This was a woman, this was a man, and so on and so forth. So the computer finds problems in information and fills them with things that might be fitting in there. NVIDIA then made that actually into a product. So there's a product that you can actually download in their 3D set that takes pixelated images and puts them in the round square, put the pixels in there that are missing. They can only do that with images that are known. But the good thing is, like with Google, Amazon, Microsoft, and others, we got trillions and trillions of photos on the web. Trillions and trillions of photos that have been analyzed, that have been recognized, and we can compare them with what you have. So if you have a picture of the Golden Gate Bridge, it's not a problem to actually give you a better version of that. If it's a picture of your kitchen sink, hopefully there's no information out there of your kitchen sink, but probably there will be. So the next thing computers are really good at is recognizing and categorizing things for us. You probably realize that when you go on Facebook and you upload a photo, it recognizes your friends already in the photo if you tag them once. Normal people should be scared by that. People should be like, what the hell is going on? But it's convenient, isn't it? Like, why should I, knowing that this is a picture of my dog, go through all of my photos over and over again and tag them again as pictures of my dog? Because I gave the computer, I gave the system permission to realize that this is my dog and tell the world that this is my dog. And the same thing happens in things like Google Photos or Microsoft Photos. So there, the example that I have here is I type in selfie, and it recognizes pictures of me looking into the camera stupidly or whatever. And I never tagged them as selfie. I never described them as selfie. That would be embarrassing, right? But the computer realized, like, if the huge part of the picture is a face and it's staring at the camera and there's something in the background, it's probably a selfie. And I upload so many photos, I don't find my own stuff any longer. So I need to actually have a machine like that doing that for me. So it recognizes where I am, it recognizes what I've done. That's it. Let's go drink. I love that I'm giving a talk like, please trust computers, and this is what's happening. But going through my own photos, it recognizes me, it recognizes places where it's there, it recognizes even things that I didn't put in there. Another example that you have to imagine in your head right now is a picture of cats where I typed in Katze, the search term, the German word for cat. I never tag anything in German, but the computer did like a Katze search, realized there's nothing what that even might mean. Hey, maybe it's another language. Let's translate it to English and then do a search with that. Google Photos, Microsoft Photos, other services do these things for you. And I mean, how amazing is it that we find our own information that way rather than us spending hours and hours categorizing our own things? Other things, you can type in food, and it will recognize that this is food, that this is sushi, this is a soup bowl. These are all these things. And all of these are not done by humans. They don't have like lots and lots of people in the basement that they don't feed until they type in that soup is that. That's actually machine deep learning algorithms going through trillions and trillions of photos and having been trained the right way to recognize what is food and what isn't food. What is a cat, what is a dog? If a dog has these little pointy ears and whiskers, it's probably a cat. This is what these machines are doing. And as machines don't get bored, they can do it over and over and over again. That comparison is not boring them, it's not tiring them out, as it would humans. Now, if you go to Google Maps, for example, you can enter a sentence in there. You cannot only say, like, get me to Zagreb, but the example that I would have had is, take me from here to the capital of Denmark. I would never type that in because I'm a developer. You know, I worked on Yahoo Maps. I know that keywords are the things to do. But we trained people to be robots. Why? computers are clever enough to do natural language processing, so I can type in a sentence like, take me from here to the capital of Denmark, and here is recognized like, where's the computer or where's the mobile phone at the moment, because it's a very simple term to find. And then the capital of Denmark, okay, let's do a search and ask Bing or ask Google, what's the capital of Denmark? Okay, it's Copenhagen. And then it showed me the map immediately between here and Copenhagen, and I didn't have to be a person that knew what the capital of Denmark was. The other option is if you upload a photo to Facebook, and you can see it here, it creates an alternative text for you. So if you do your developer tools and you open them, or you actually do a search, it will have a picture of a dog, and it says like, image may contain dog outdoor grass. So what this did is use, again, machine learning to give an alternative text to images that didn't have an alternative text, which is important for people who can't see, but also for other computers. So basically a search engine that finds this information will now find your website by saying dog and outdoor, and not only there's just an image, I don't know what that is. And again, you don't have to type that in, machines can do that for you. This is ingrained in lots and lots of services. We even have it in PowerPoint. So if you're in the newest PowerPoint online, if you drag an image in there, it says like, hey, here's an alternative text. Is that okay? Or do you want to type something extra in there? And how good is that? How good is that extra work that we had to do that a computer does it for them? You know, if PowerPoint does something useful, we have no excuse anymore for our software not to do something useful. We built a system called Captionbot.ai. If you want to try that out, where you can upload a photo and it then gives you a full sentence of what that might be. So the photo in your head right now is a man on a skateboard jumping, and the description that the Captionbot.ai gave you is, I think it's a young man doing a trick on a skateboard. And this is not man, skateboard, jump. This is a full sentence coming out of doing the image analysis, finding the information in the image, and then making a sentence out of it using yet another machine learning algorithm to make a sentence out of it that makes sense for humans. This is how we interact already with our mobile phones, with Alexa Home, with like Google Home, these kind of things. People talk to their computers and expect them to give them human answers back. And we can do these things, and we don't have to be these large, amazing companies to do that. There's a company called Ipollin in America, and they even went further with that. They have a phone app for blind people that just film. They can do it vertically because nobody's going to see it. They just film the environment, and it tells them what's there. It says like, okay, here's a chair, here's a table, here's a Coke can, here's a drunk person, these kind of things. We used the Captionbot AI to do something similar for a blind friend of mine. So he had like smart glasses, so he can take a picture, and it says like, there's a man next to you, he looks bored, so probably you should say something different. But this one does it as a neural network on the machine itself, on the mobile phone itself. And that's pretty amazing that technology can do that nowadays. And this is the next step. I'm already talking about old stuff here. When you listen to the videos we just had at Microsoft Build or at Google I/O as well, all of this machine learning stuff is going into databases, it's going into the chipsets itself. Apple is working on a chipset that does these image analysis and language analysis on the chip with you having to go through the cloud and using these services already. So we're there already. Now, the other thing that we have is chat systems, especially in the Asian market, that translate while you actually type. So the person typing in English, the other person gets it in their language. And even when they speak into it, it translates it into the other language. There's a preview right now that you can download again for PowerPoint, where I could stand in front of my computer and present, and it automatically translates what I'm saying into subtitles. But you could connect with your phone, and that's any phone, not a Microsoft phone, because nobody has those. You can connect with your phone to the system and see the subtitles in your language. And I saw that, and I was like, this is Star Trek. We are here. This is freaking cool. I want to have more of that. This is pretty amazing. So this is what computers are doing for us. Google's Allo does another thing where you upload a photo, and then it automatically gives you answers when you get a photo from somebody else. It analyzes the content of the photo and then gives you 3 buttons to answer. So the demo here is linguine, like the pasta, and the answers that Google Allo offers you with one click of a button is saying like, yum linguine, or I love Italian food. So this is really, really useful if you're on the go and you want to quickly answer something. But I find it kind of like non-human. You know, if I don't have time to answer your text, why the hell did I read your text? You know, I shouldn't give you the impression that I have time for you if I don't have time for you. And kind of like if we get these images coming to me and me choosing an algorithmic answer to go back to you, what are we for? Are we a transportation service for computers to talk to each other? That's kind of like taking the human out of the equation, but the technology behind it is pretty incredible. Now, other things I've been having here is that, for example, in China, there's a company that just automated completely. There's no on the shop floor where they build cars. There's no human involved anymore. It's just robots controlling robots, building cars, and they got like an 80% rise in productivity, and they got a 50% less people getting sick. And this is, I'm invited to the German government as an expert about machine learning and automation, and everybody's afraid of like, oh my God, human jobs are going to get away. Well, these are jobs that should get away. These are jobs that make us sick. These are jobs that make us bored. These are jobs that we are too bored to do. That's why we make bad quality stuff. Having to do the same job over and over and over again is bad for humans, and they don't want to do it. So we shouldn't have these jobs. Computers and robots are happy to do these jobs for us. Now, the next section I want to talk about is what we can do with enabling here. Now, a few years ago, all of these things that you just saw have been science fiction. We saw it in Star Trek, and we're like, oh, we can never talk to a computer. The computer will never be able to translate some alien coming in and talking to Captain Kirk. That's just the future. But we have it right now. These things are already not science fiction any longer. And the problem, though, is like it seems to be too hard to do. We all see the press about machine learning and artificial intelligence is a thing that Microsoft, Google, Amazon, Facebook, and all the other cool, clever kids in the Silicon Valley are doing, and we are all too stupid for that. But it's not. And to a degree, first of all, I'm very excited to work with data scientists. I'm very excited to talk with people at like machine learning conferences because I feel like an idiot. You know, I feel stupid, I feel out of my depth, but the people around me are super diverse. You know, you have lots of people who are in their 50s, you have a lot of women, you have a lot of like people from ethnic backgrounds that you don't expect normally to be at conferences because it's a human thing. We have to analyze data, and if only a white person who's 19 years old in the Silicon Valley makes a training data set for artificial intelligence, of course there's only going to be results for white humans coming out of that one. We need more diversity in the teams that do these kind of things, so instead we're actually not discriminating with our technology. There was a big case where Google's photos tagged people of color as gorilla. And the reason was not that this was racism by Google, the reason was that the data set didn't have enough picture of people of color in the data set. It was a small data set that they trained it with. So they took the next thing that was round and dark, so hey, maybe it's that. Is that okay? For a computer, it was okay. For a human, it's utterly not okay. But it was all a data problem, and this is where we all come in. You have to train your data the right way so the results are good for the humans that use your systems. And if they're not enough data, then you should do something about it. The trick to understand these all things, and I'm a JavaScript developer. I love working on the metal. I love working with a text editor and a browser, and I want to do everything myself, and I hate every other programmer because they're obviously not as good as me. So I want to do everything myself. But we have to understand that this is over. We have to understand that we live in a world of clouds and services and products. So you should not feel bad of taking three things, putting them together, and making something out of it. The games industry has done that for years. Nobody writes assembler code to write games any longer. Everybody just uses libraries that work with different hardware and different software and different graphics cards, so you don't have to do these kind of things themselves. Now, all the players are doing the same things. There is a great talk at Google I/O by Amy, a friend of mine who helped me with these slides as well, because I was using some of her examples that you can't see. She gave a talk about what Google does in machine learning and explains machine learning first and then shows some of their services, which does the same stuff that everybody else offers, that we offer as well in our cognitive services. And you can use these systems for your products. And this is what I'm begging you to think about right now. Don't let only the big players in the Google Homes and the Alexas and these kind of things use this technology. Make your interfaces more human by leveraging, oh God, I just used the word leveraging, by using the systems that other people give you. Use Google, use Amazon, use Microsoft, use a startup if you want to. Just make sure that you understand that machine learning is huge. It needs a massive amount of computers, a massive amount of computing power, so you probably don't want to maintain and buy these computers yourself. So using a cloud service for that makes it much easier for everybody involved. Almost every company offers APIs for this, and they have REST endpoints. So I don't care if you use Python, PHP, Java, Ruby, Haskell, JavaScript, whatever you want. It's just a REST API. So you throw things at it, and you get JSON back. So you put images in there, and you get a description what the image is about, what's on that image, if there's faces in the image, what these faces are they male, female, what age they might be, the emotions that are in these faces. You throw text to it, it gives you a translation of the text, it analyzes the text for you, and gives you only the keywords in that text for you. All these things are available for you as APIs. A lot of this work went into these APIs, and you might not want to do that yourself. Because machines are doing, and the people writing these APIs, we realize that if you send us a picture and you get back 3 keywords, is not good enough. If you send us a text and we basically tell you that's English, but we have no idea what it is, that's not a good result either. So we made these APIs go deeper and deeper under the hood, and you don't need to know about that functionality. You don't need to know about that technology. You can just concentrate on making an interface that humans are not afraid of, that humans are not scared of. We harvested tons and tons of data over the years. You all, well, probably not you, but me and other people have happily uploaded tons of stuff to Facebook, not realizing that for years and years it's been using our stuff to sell to advertisers and also analyze it and make a massive database out of it. The good thing is that Facebook and others are now opening up to us developers to use this stuff to do some good as well, and not only advertisers. I always find it fascinating that advertising is on the forefront of artificial intelligence, and yet it does stupid things all the time. I bought a suitcase on Amazon the other day, and it has a lifetime guarantee. So if I tell a computer, this man bought a suitcase that whenever it breaks, he can get it replaced for free, why the hell do I see advertising for more suitcases? You know, it's not like you buy a suitcase every day. It doesn't make any sense. The people running these machines are not as clever as the computers are. So the biggest problem to understand is to understand the data. It was a mess. People uploading pictures without tagging them, people typing things wrong, people misunderstanding things, and every search box on the web should allow me to make a mistake, to type something in the wrong way so I can still get a result. Google does that, Bing does that, Yahoo does that, everybody does that, but our internal searches on our websites don't do that yet. So we train machines in thousands of iterations to get the best information out of a small set of data. If you take a sentence, what computers do is they don't only see that sentence, they cut it down into words. And they realize which word is dependent on which other word. And then they start going into the syntax of it. Then they go into grammar and understand that this is a verb, this is a subject, this is an adjective. And then they actually stem further and say, like, if something is called helps, the stemming is help. So if somebody types in help, that should be the same result that helps. So we made computers go through the syntax and also the meaning of the words to give us better results, and we don't do that as humans normally. We just said, you made a typo, I'm not going to answer your email. But we went deep down the rabbit hole in all these APIs to give you natural language processing. There's a system by Microsoft called LUIS. There's TensorFlow has a lot of stuff. AWS has a lot of stuff where you can say, okay, I want any input from users to be understood this way. So if there's a sentence that says flight, give it flight results. If there's a sentence that said plane, give it a flight result. And then the machine churns through it, and you get more information on top of it. So it realizes Flugzeug in German is also plane, so it will also give you an answer to that one. So you can train the machine to understand humans with graphical interfaces. You don't even need to do that on a computational level, you can actually be somebody who's more confident to actually use a graphical interface to connect things with each other and say like, if a sentence contains that word, do that. So you have these like workflow things like you have in, for example, phone systems as well. So I click through a lot of stuff that you can't see right now. And the main thing what we did with that is better translation. Because translation originally was just word by word. And of course that means terrible translation. If we translate our own things and we do it word by word, nothing sensible comes out. So when I translate from French to English, for example, or from German to French, I do it word by word, and then I look at the whole text and rewrite it again. Because I rewrite it then in a more flowing, more human understandable way than just word-by-word translation. They can only get us so far. So by analyzing the syntax, by analyzing the grammar of the language that we used, we actually have much better translation results. And Google has like 80 languages. We've got a lot of them as well. And this is even live working on audio, on video, and on text right now. So being translating on your website with a Bing button is probably kind of lazy, but if there's no other way for people to do it, they use, no, even my screen is now dead, actually. People use translation systems to access, for example, websites that have been blocked. I've seen universities that use translation, Google Translate, to translate a website from English to English so they can access it in their university. And that's quite an interesting one to do. So can we do something about this? I've got nothing now, at all. Okay, so let's go further with that. Let me think what the next bits were that I wanted to talk about. Now, if you have graphical information, you can use these services to get some things out of them. We have called cognitive services in Microsoft, where you have 5,000 hits a day to an endpoint where you upload your image and you get a transcription back. You get a transcription back, you get the colors used in that image back, you get back what the image is about, and you can actually then see faces in these things as well. So you recognize there's a man swimming in a swimming pool, so you get tags of saying like swimming pool, face is at this direction and that place. And the facial recognition goes so far that it doesn't only give you, say, like there's a face in there, but it tells you all the 3 angles. So you can say like, it's like this, that, this, that, this, that. And that way you can actually put things on a face like Snapchat does with filters. But it also is very important for recognizing and recognizing faces and doing something with them. I'm working with a supermarket chain right now, where you look into a checkout and you pay. How much better is that than having to have money or having to put your credit card in? How many times have you been in a supermarket with some elderly person in front of you that put their card in and then went into their wallet and had their PIN number this big on a piece of paper because they keep forgetting it? Why do we need to go through these stuff when we've been analyzed, when we've been found out, when we know already who's been there? Of course this is creepy, of course this is scary, but it's already too late. If you have been at any airport in the last 10 years, if you have been at any train station, your face is recognized. You are known. Your passports are machine readable. We already are beyond the watershed there. We're actually in this space where we now should do something useful with it. I like, for example, Google Hello. I look into my computer and it recognizes me and I logged in. Phones do the same thing with fingerprints right now, and of course it's hackable. The Chaos Computer Club just hacked the new Samsung phone and said like, I can just show it a picture. It doesn't work on a Surface Book because we actually have 2 cameras, so it actually looks at 2 angles, and it does an infrared camera in there as well. That's why these things are so expensive. So it realizes that I'm alive and I have a pulse. So if I just show you a picture or a sculpt of my head, it wouldn't work. The same way any finger reader should actually recognize the temperature and also if there's a pulse in it. So again, if we think like, okay, this is just creepy and nobody thought about this, security people have been thinking a lot about what's going on there. And you can build these things into your systems as well. We're working on a W3C standard now to allow you to log into our website with biometric data, which might be fingers, which might be your face, depending on what the operating system and what the machine that you're using does right now. And if that fails, just give people a text field and let them log in with the system. But please do not just have a password field and a text field. this is over. It has to be a two-factor authentication. It's too easy to crack things that are just a password field, and people don't remember passwords. People don't use passwords. If every time there's a hack, there's a great data set I could show you on GitHub that shows you all the passwords that people have been using. Oh my God. That people have been using. And it's things like password 123, and it's like baseball, let me in, stupid computer, why are you asking again, these kind of things. So people are using human passwords, which are very easy for computers to crack. I think my most favorite thing that happened lately was when a researcher, you know, Google's reCAPTCHA, that are these distorted images, and you have to type them in. If you're blind, of course, it's hard for you to see the distorted images, right? So it has an audio capture as a fallback. So you can type on it, it says something, and you have to type that in. Now, what the researcher did is to use Google's image recognition to turn that audio, audio recognition, to turn that audio into text and then send it back to reCAPTCHA. So it used two Google APIs to crack each other. And I love that because they come from the same resource. They came from the trusted Google computer, so that's not a problem, right? So evil people will be much better in using these technologies than we are, so let's make sure we're actually better than those people and do something useful with it. Now, the last thing that I think I had on my slides, if they're ever gonna, yeah, fuck it, is that we should use these systems. And I'm happy to talk to you all day about this and show you some things as well on my computer, which I know that works. The last thing I want you to think about is preventing people from doing stupid things. So again, you remember Word telling you this was wrong. Please, if you do an upload on your websites, generate some text for people and say like, hey, just posting the image is not good enough. Here's an alternative text. Is that alternative text good for you? Go with it. WordPress has plugins for that. Other systems have plugins for that. It's a very, very simple thing to do. Another thing you can do with machine learning and images is do boring tasks for your graphical designers. Thumbnail generation is frigging boring. It's a very, very stupid thing that a designer has to do all the time. So what you can do instead is, oh God, yeah. What you can do instead is use a service like Cloudinary or directly our service or Google service for that. What it does for you is analyzes the image and finds out where the faces are, and then centers it on that and cuts around it in the size that you want. So instead of having a massive picture turn into a pixel mess that nobody understands, what you have is then a thumbnail that shows only the most important part of that page. So if your thumbnails are about a company logo, for example, it would center and resize that logo to be still legible rather than having like a big wide thumbnail with the text this big in the middle. And this can be all batched. This can be done on thousands and thousands of images without a designer having to do that, because their job should be to build UX, to build UI, to basically do the interfaces that make things more human. The last thing to actually talk about when it comes to protecting our users is think about moderation APIs. Google has it, Microsoft has it, Facebook has it, Amazon has it. And we've been working on those for decades now, together with the police, together with governments, to make sure that you not only know when a picture is racy or when a picture is adult, but when a picture has child pornography in it, no human should ever see this. This should never end up on the internet. So what these moderation APIs do is find out illegal content that is already known and automatically delete it without you having to know and without your end users ever having to consume that. So computers are totally okay to see things that humans should never see. So let them see that and not your end users. If you allow people to upload random stuff on the web, it will take 2 or 3 minutes and the first terrible thing will come out there that you should never show to end users. So letting the machines that have been trained to recognize things that are not there to be shown on the web is the right thing to do to filter out and make sure you protect your end users. William Gibson, the science fiction author, has said that the future is already here. It's just not evenly distributed. So I hope today, with all the demos that I showed and with all the things that I talked about, And please talk to me and other people out there. There's so many things you can do to make our interfaces more human. It's not that you have to become Siri, Cortana, or whatever OK Google is, but make sure that you use and use these services to the power that they have to build human interfaces, because we're already in the robot takeover. We're not going to be a Terminator world anytime soon, but we should be building more human interfaces because computers can do things that humans are too good for. And with that, I think I'm out of time. Thank you very much.